Okay, I hope you can hear me well. Again, my name is Ilia Chernov. Thanks to my colleague for introducing me. And today I'll present you an approach which may help you to save a lot of time while working with tests by caching the Spring context. And again, I'm from Wrike. A lot of words about Wrike was said today. And here are a few words about me. It's me. And besides Wrike, I'm also a student, and I'm interested in reinforcement learning because I find this stuff pretty exciting. And also like learning new IT stuff in general. And this is basically how this project was born. So basically, I tried to solve my problem, plus it was a good opportunity to try new tools. So today, I'll present you an idea how you can speed up the tests, working with tests. I'll present you IntelliJ IDEA plugin, which implements this idea and utilizes the hotswap for it. And as a bonus, I'll show you how to create a custom hotswap agent plugin and why you might want to do so. And at the last part, there will be some code. So I hope I will not lose you. Okay. So as developers, we more or less every day spend working with tests. And I'm sure if you are using Spring, you spend a lot of time idle because how Spring works. And this is because basically Spring takes a lot of time to initialize its context. And in my experience in Wrike with the current laptop, it may take up to several minutes, like up to 3 minutes to start up the context. And I can even forget why I started the test in the first place. But I'm happy that my laptop will be replaced soon enough, so it will not be such a problem. But anyway, so basically every time I have to restart the test because I write another test or fix the bug or missed a function to step into during debugging, I have to wait some time till the Spring context initializes itself. And I asked myself, can I do something with it? And it turned out that yes, I can. And here's the idea. So first of all, we want to reuse the Spring context. And for this, we will keep the JVM alive between test runs. So we will not shut down it after tests are completed. And here the question arises, how will we actually update the code if our JVM always up and running? And for this, we will use the feature of the JVM hotswap, and we also will utilize the power of the CVM and hotswap agent. And I'll show you why later. And finally, let's create a plugin for IntelliJ IDEA, which wraps all of its ideas, and just to make it easy to use. So here is how the whole process will look like. So first, the idea exists and the developer using it, and the developer asks IDEA to start the tests. So first step is for IDEA is to start up the JVM with the test executor in it. And this test executor is basically just a main method which knows how to communicate with IntelliJ IDEA and knows how to start up the tests. Then IDEA sent a command to this test executor to start the tests. And test executor starts the tests. And these tests are responsible for initializing the Spring context and caching of it. And when the tests are completed, we keep the JVM alive with the cached Spring context in it, so we can reuse it later. Then, for example, the developer made some fixes or added another tests and ask IDEA to run tests again. IDEA will compile updated classes, do the hot swap of them, and ask test executor to run tests again with the same JVM. And the newly created test will reuse already initialized Spring context. And here we save the time. Let's now go step by step through the idea. And we'll start with reusing the Spring context. And the main question here is, how will we actually cache the context? And the answer is simple. We don't have to do anything because, as usual, Spring already does it for us. And in reality, under the hood, there is a so-called context cache variable, which caches the context. And it is initialized as a static final variable, so it is naturally reused through the whole life of the JVM, so we don't have to do anything. And another important feature here is that Spring doesn't actually close the context after tests are completed, unless you are using dirty context annotation, but I guess if you are using it, you probably know what you are doing. So next step is a hot swap. And I mentioned the CVM and why I'm even mentioning it. So basically the problem is that the default feature, hot swap feature of the JVM supports only redefinition of the method bodies, which is obviously not enough for the comfort development. That indeed isn't used usually by the developers. So this is why we want to use the CVM, because it basically enables us much more use cases for the hot swap. But you still can see that not all cases are supported, so you just have to be aware of it. But from practice, it's still much better and actually kind of enough for the development. And what is actually the CVM? So first of all, it's a hotspot modification, which updates how hot swap process working. And it was first time implemented as a PhD work and distributed as an open source project. And starting with Java 17, it is distributed with the JetBrains runtime, which is basically an OpenJDK fork with several bug fixes, performance improvements, and other features like the CVM. But if you're using other Java version, there is also a possibility to use the CVM. You again have to install specific JVM implementation, but kind of other. I just refer to the official instructions. So how this thing works? The whole process of the hot swap starts with the class redefinition command, which may come from the debugger, for example, which is used by the developer. And the first step is to find all affected classes. And this is required for supporting cases like when you, for example, update a superclass, all the subclasses also have to be updated because they are dependent on the structure of this superclass. Then all collected classes are sorted topologically, and after that loaded to the JVM in the sorted order. And we had to sort it again just to load the superclasses first, and after them all the subclasses. And at this step, we're building so-called site type universe, meaning that both versions of the classes coexist in the JVM. And actually, JVM is still up and running, meaning our program on the JVM is still up and running. But now we want to stop it to perform several operations with the data. So we ask all threads to stop at the save points. And first operation is to update all the pointers to old class versions to the new class versions. So next step is to update such instances which should be either decreased in size or increased in size. Oh, sorry, decreased in size or not changed in size. This update happens in place, and this is to support the cases when we, for example, removed a field from using the hot swap or removed a field and added another field. So we just have to update the context of the object instances. Next step is to deal with the instances which should be increased in size. And this is done through the modified garbage collection process. And this is basically allocating more memory for them and moving these objects to another place. And the final step is to invalidate some part of the JVM state. And this is, for example, like de-optimizing optimized native code because it may be not compatible with the current state, or clear some caches or rebuild some data structures, this kind of stuff. And after all those operations, the hot swap process is completed and our program can continue running. And I took this diagram from the PhD work itself. So in case you're interested in more details, I suggest you to go to this PhD work. It contains a lot of them. And also you can see that the fair hotswap process is performed here. So no additional abstractions, nothing like that. So there is actually no performance overhead or memory overhead, except that after the hotswap, caches are resetted. So they have to be fulfilled again. Now, let's consider another problem. How would our generic framework works like? So first of all, it usually builds some initial state. For example, in case of Spring, it's a Spring context. And then the framework uses the state to do some useful work. Why we are using this framework in the first place. And then the developer comes and asks some classes to be redefined. And the question here is, how will we update the state? And we may want to do so because the state may be dependent on the classes which were redefined. So after the redefinition, the state is kind of invalid right now. And with this problem, hotswap agent will help us. And hotswap agent is basically a Java agent, which makes it convenient to update the application state when the class or resource is updated. It has plugin system, which makes it pretty extensible. And the cool thing is that it already has a bunch of built-in plugins for different frameworks and instruments. But the unfortunate thing is that they may not always be working. For example, specific version may not be supported, or the functionality which you are using may not be supported. But the good news is that you can actually write plugins by yourself, meaning that you may want to support what you actually want, even the custom frameworks inside your company, for example. And here is how our diagram will look with the hotswap agent. So first of all, hotswap agent is added with a bunch of plugins in it. And when the classes are redefined, hotswap agent intercepts this event, and plugins have a chance to analyze this event and update state if required. And before we move further, I want to mention JRebel, which is basically alternative to the technology bundle which I presented to you, the CVM and hotswap agent. And the main reason I didn't choose it is because this project was started as a pet project, prototype, and I didn't want to spend any money on it, but the JRebel actually costs money. So that is the reason. But people say that it has better support for different frameworks and more hotswap features, so it may be a reasonable choice. But in practice, I find the CVM and hotswap agent is pretty good choice, and they are covering most of the cases. And the final part left here is the plugin, and finally demo time. So here I have a small Spring Boot application. I hope it's readable, with the one bin in it. And in constructor of the bin, I placed a thread sleep for 3 seconds to simulate long context startup. Now proceed to the test, and let's say we want to run tests from this class. We press this button as usual and see that another option is added. We press it. So the JVM will be started. Spring will take some time to initialize its context, as you can expect, and the test will be completed. And let's say we want to run this test again. We press this button again, and it runs constantly because, again, the JVM was still up and running, the Spring context was cached in it, and we didn't have to initialize it. And let's say we want to change the logic of our service, and we update just the string which is returned by this service, and run tests again. And those should fail, I hope. Right. So the hotswap is working. and we can update the logic of our services in runtime. Also, let's say we want to add another test and run tests again from this class. And now both tests will be run. So we can add tests ad hoc without a problem. And also you can imagine the situation when different test classes uses the same Spring context. So using the Sage VM with the same Spring context, you can actually run the test from another test class without any problem, like this. And that's basically it for the main functionality of the plugin. It also supports running regular applications, plus has several settings, but that's not what is interesting right now. So I'll not show it. And now we'll proceed to the final part of the presentation, custom hotswap agent plugin. And I will show it on example with MyBatis. And you may ask why MyBatis, and I'll answer that just because we're using it in Wrike, and we actually wanted to have this plugin. So this was the reason to implement it. And before we proceed, a few words about MyBatis. What is it? It's another one persistent framework for working with relational databases. And working with MyBatis, you're working with native SQL, and MyBatis handles all the job with the JDBC. Plus, it can map from SQL results to the objects and has several other features which are not important right now. And one way to configure MyBatis is through XML configuration. And for this, you have to create an interface, so-called mapper interface, with the methods in it. And each method will correspond to the SQL queries. And also we have to create an XML file with the actual SQL query in it. And you can see that all the interesting stuff is happening in this XML file, which is not really cool because like big gap between these files. But the good thing is that actually there is an annotation API with which you can specify SQL queries right in annotation, and which looks much better. And this is the thing which we're using in Wrike. And let's consider this problem. So we have this query and we want it, let's say, updated to this select2. And we do this update, we do the hot swap and expect everything is working right now, but it's not. Because in reality, MyBatis has a query cache in it, and cache still contains select1. And this is why this query is performed by the application, even if you updated this annotation. And this is why we want hotswap agent plugin. And also in reality, hotswap agent already has plugin for MyBatis, but unfortunately, it has only support for XML and no annotation support. And again, this is why we want to implement another one plugin, which will support annotations. And first thing to do is to register our plugin in the hotswap agent ecosystem. And to do this, we just create a class for our plugin annotated with the plugin annotation. And plus, we also have to say for hotswap agent where to search for our plugins. And we do it through the properties file where we specify the package with our plugins. So simple as that. And before we start do some coding, let's think about what will actually happen, how it will work. So for this, we will consider this huge configuration class inside MyBatis, which basically contains a lot of different configurations, including query cache, which we are interested right now. And on the other side, we as users specified several mappers with the SQL queries, and now we want to fulfill this query cache with our SQL queries. And we do it through the so-called mapper registry, which has add mapper method. We just pass mappers, one by one through this method, and this mapper registry fulfills the query cache. But also here we want to save all this information inside MyBatis plugin. And I mean, to save the references to the configuration instance and to save to set of plugins which are related to this configuration. So we can use it later. And obviously mapper registry doesn't know anything about this MyBatis plugin, because why would it, right? And what we will do, actually, we will instrument this add mapper method, adding some custom logic in it, and we just will call method of our plugin to save the references to configuration instance and set of mappers. And let's say the developer comes, updates the query, do the hot swap, and we right now have to update the query cache. So the new query will be used by the application. And then MyBatis plugin receives this event that our mapper was updated. And the first thing to do is to reset completely this query cache. And again, we have reference to the configuration instance, and we can do so. Then we just add one by one mappers through the mapper registry to the configuration to fulfill our query cache again with the new values. And this is basically the whole workflow. And now let's take a look at the code and how will we update the add mapper method. And this is the most interesting part of this method. And here you can see that there is a try block where mapper is actually parsed and the caches are fulfilled. And what we want to do, we want to insert our code right after successful mapper parsing. And what we want to do there, we want to get the instance of our plugin using hotswap agent API, and then call the method of this plugin, passing to it mapper class and configuration instance, just to save this information inside our plugin. But before we do this, we also have to initialize our plugin. And we, again, using hotswap agent helper methods, do this. And during this initialization, instance of our plugin is initialized for the current class loader. And services of the hotswap agent may be injected in our plugin if required. So then to do this operation, just actually to update this mapper, we will use Java assist library, which is actually used by the hotswap agent. And this is basically the bytecode manipulation library. And the interesting feature of it is that it can work on both levels, like source level code and bytecode level. And let's take a look at a quick example. So here's the class pool, which is basically a cache of classes. And we creating a class using this class pool and a method for this class. And then just add the method to this class. So we constructed this class like this. And pay attention that we creating this method using just raw string with the Java source code, which is then parsed and compiled to the bytecode, which is used then to create the method, which is cool in my opinion. And makes it very convenient, very easy to use this tool. And you don't have to be a guru and know how bytecode works. But the worst thing to note here is that the Java version which is used in this source code is not the actual Java version which is used by your in your project. So just be aware of it. And in reality, it's like Java 7 or something like that. So not all features may be present, but still it's good enough. And here's basically how we will update mapper registry class. And to do this, we create a method inside our plugin and annotate it with on-class load event annotation, basically saying that we want this method to be called when the mapper registry class is first time defined. And we receive two parameters. First one is mapper registry class in terms of Java Assist API and the class pool. And then we use those parameters to get this add mapper method and then to insert the code, our code inside this method. And what code do we insert? Again, it's just a simple string which we built using hotswap agent helper methods. And first method builds a call. Again, it's just a string with the call with the Java source code, which calls the initialization procedure of the plugin. And the second one just builds a call to the method of the mapper. And basically we call here, you can see the register mapper class. And this method basically builds two maps. First one is from configuration instance to the set of mappers, which belongs to this configuration. And another one just vice versa. Mapper class to the set of configurations. And now we want to do something when the mapper is redefined. So for this, we again create a method inside our plugin, annotated with on-class load event, and using regular expressions saying that we want this method to be called when any class is redefined. And we accept in our method the class which was redefined. And then using the map built on the previous step, we just collect the configuration which belongs to this mapper. And if we found any, do the refresh of these configurations. And you can see that this method, actually can accept any class, not only mapper classes. But in reality, we will just skip those because there is no configuration for such classes, right? And before we look at how configurations actually refreshed, let's consider this case. So here, how our working schema looks like right now. So basically, we just receive the mapper and call the refresh configuration procedure. But what if the developer will modify several mappers at once? So with the current schema, on mapper redefined will be called several times in a row, and then configurations will be refreshed several times, which is basically redundant. And to avoid this, we will change the working schema to look like this. So basically, instead of directly calling refresh configuration procedure, we will first create a refresh command and then send this command to the so-called scheduler with some delay. And this command and the scheduler knows how to merge the commands together. So basically, if several mappers will be redefined, few refresh commands will be created, for example, 3. And if they are generated during this delayed time frame, they will be all merged together, and configurations will be updated only once. So basically, this is a batching process. And this scheduler component is actually just a hotswap agent service, which is provided to us during initialization steps. So we don't have to implement it, just need to use it. And this is basically what we will do in our refresh configurations method. We first collect map of configurations to the set of mappers, which belongs to this configuration, and then creates a command and ask the scheduler to schedule the command, and ask the scheduler to execute this command after 1 second. And meaning that our batch time frame is this 1 second. And the last part is our refresh command. And here we basically iterate through each configuration, resets it, meaning that we reset the query cache, and then add a mapper one by one to this configuration. So simple as that. And looks like this is it. Let's check it out. So here again, we have a small Spring Boot application with the one MyBatis mapper in it and with the select one query. And first time we will execute the test. And then we will update this query to select two, for example, and we'll rerun tests expecting that it will fail, meaning that we will use basically new query, new value will be returned, which is not expected, and the test will fail. And so we'll change the value, run test again. But it's still green, unfortunately. And do you have an idea what was wrong? I'll provide just a few options for you. First one is either configuration caches are not reset, or refresh configuration command was not executed, or it's not executed yet, or its annotation value was not redefined at all. What do you think? Yes, but you saw this presentation. Right, it's 3. Okay, if we run tests again, the test will be red. Meaning that the configuration is actually eventually refreshed, but the test was able to be executed before this. And if you remember, we asked the scheduler to run the command after 1 second. So this is basically why this is happening. And that felt kind of bad because like we're pretty close to the working prototype, but it's still not working. But the cool thing is that fix was actually pretty simple. So here we basically have completely separated our plugin and the test, and we want to synchronize them. So for this, we will introduce a lock, as usually it's done. And we will use this lock, try to acquire it before the command is scheduled, and to release it after the command is completed. And also to use this lock from the test side, we will add so-called suite listener, which has 2 methods on start and finish. First method starts before the tests are started, and the second one right after tests are completed. And we again will try to acquire and release the lock from these methods. And from this schema, you can see 2 possible scenarios, basically. First time is when MyBatis plugin will acquire lock first. And this is actually what we want to achieve. So the test after that will wait until the command is completed before they start. But the second scenario is when the test will acquire lock first, and then they will wait. They will not wait till the command is completed. So meaning that they can use stale configuration, which is bad, which we're trying to avoid. But in reality, this before schedule block is happening during hotswap process. And if you remember, I showed that hotswap is happening first, and after this, we asking test to be executed, meaning that MyBatis plugin will always try to acquire lock first, meaning that this is a valid solution. And the fix is pretty quick. So here's the suite listener. We basically want it to look like this. Again, we are using hotswap agent API to get the instance of plugin and the call the methods on it, try to acquire the lock and to release the lock. Plus, we want to update this code where we schedule the command, and we want to look at like this. Basically, again, we try to acquire lock, as I said, right before the command is scheduled, and try to release it right after the command is completed. And we do it by passing the lambda to this command, which will be executed after the command is completed. And let's check if it will work like this. So for this, we will roll back quickly, fix the plugin. Run test again. Then we update the query, run test again. And now they read. So everything is working fine, finally. And conclusions. So I hope I showed that hotswap is indeed useful in testing. And I showed an example with Spring, but you can imagine it will work with any tool which requires long initialization time, but can be reused afterwards, like test containers, for example. Also, we saw that DCVM and hotswap agent is a powerful combination, which makes actually hotswap in Java useful, at least. But unfortunately, they not always work. You just have to be aware of it. But the cool thing is that you actually can write a plugins for hotswap agent, which makes it pretty customizable. So you can even support your internal frameworks for your company. And finally, I presented you a prototype of the IntelliJ IDEA plugin, which helps you to save the time. And it works well, but unfortunately, I can't publish it right now. So, but if you want to try to use it, you can write to me or join Wrike, because we're using it. And again, some ads about our tech lab. Also join it. And if you have some questions, I'm ready to answer it. And I will just leave it here.
Thank you.
Yes. Simple question. How did you found first time DCVM plugin? Because hotswap was always about changes of code inside methods, but not changes of class signature, class structure, method signature, data fields, and so on. How did you find it first time?
Google.
Google what?
I mean, I just tried to Google hotswap in Java, and after some links, I found DCVM and JRebel.
Oh, maybe because of promotion of JRebel. Thank you.
It's not really hidden.
It's not a modern way. For now, we will ask ChatGPT.
You can ask without microphone, actually, because we have silent microphone.
Okay. Have you stumbled upon a problem when test data or test states are cached with the context?
No, we usually recreate all the data from scratch in Wrike.
So
The problem for us.
each time the context is cached, data is created in U, and states are created in U as well, right? Okay.
This is how it works in Wrike. It is.
So I want to ask basically if application is running after the test, like context is active? Is context active? Oh, so that means how to destroy application, how to close it?
How to shut down JVM?
Shut down JVM.
Shut down the game from process, just kill it.
Yes, but that's the feature of the plugin that Spring Context is actually preserved, and we can run the test on it.
And is it possible to run your application not in test condition, just application with this hotspot?
Yes, you can actually use it even without this plugin. You just have to follow the instructions of the DCVM from the DCVM official instructions, basically, and it explains it all.
Thank you. A question about context load, and if we add additional bin to our test,
is it will reload context?
It's a tricky question because it is possible to do so, but it's not always will work. Meaning that to support this case, you have to have a hotswap agent plugin, and it has a plugin for Spring, but it supports not all the cases. And I'm not sure about which cases are supported. At least in Wrike it doesn't work, and in this demo example it also doesn't work because it can find some methods. So, for example, something like that. So I guess Spring Boot 3 doesn't support it by this plugin. So, but in some cases it's working, I guess.
In some cases,
In
it's
some
like I mean, I thought that we use only Spring context cache, Spring cache loader. I don't remember how it's called, and that's it. We don't rewrite. You don't rewrite this Spring cache loader. And as I remember, if we change our context in test, it always reload context data. But you told,
Can you speak a little bit louder?
okay. I think I got you. If sometimes it will work if we add bin, another bin. Okay.
I mean, it just depends, I guess, on what configurations of the Spring you are using, plus on the version of the Spring you are using.
Okay. Okay. I got it. Thank you.
But again, you can write a plugin by yourself if you really want it.
Yeah, hello, my name is Vasily. So thank you, great presentation, but I want to ask the same question about mappers. If I add some new mapper, not maybe some bin, will it hot swapped and added to my presentation, my context and used and change the SQL or not?
Basically, the same case, because usually these mappers are Spring bins. So if you are adding Spring bin to the context, it has to be somehow injected to the context. And if it's injected, I think my plugin will know about it and it will work, I think.
Okay, thank you.
Because during initialization of the mapper, it always go through this mapper registry at mapper. So the configuration is query cache is fulfilled with new queries. And this is why it should work, I think.
Okay, guys. Still have questions?
Yes, hello, thanks for presentation. I have a simple question. Yes, okay, tests take too long and yeah, we should wait, but how long does it take to provide such solution? Yeah, in terms of time, in terms of team resources and so on. So how long do you spend to provide such plugin and so on?
You're asking how long did I develop this plugin?
Yeah, sure, just...
I think it was around month, just when I had the time, like it was in parallel with usual business tasks.
Okay, guys. I have a simple question for all of you. Ilya introduced his own plugin, and if you would like to use it in your own work, you will raise the hand. Do you want? Okay, some of you interested with the plugin, and for now we have a competition. If you saw this video on YouTube, you have to put push to the heart, and if we have 500 likes with this video, maybe we will ask Ilya to publish the plugin to public marketplace.
Good
Yes?
deal.
Yeah. Okay, we have a deal, and for now, one more time, we will thank you. We will say thank you to Yeah.